Hello and welcome to this video on log investigation and analysis. In today's episode, we will be discussing how to effectively analyze and interpret log data to detect anomalies, identify security incidents, and troubleshoot problems. We hope that by the end of this video, you will have a better understanding of how to use logs to your advantage in your work as an IT professional or system administrator. You will be able to effectively detect and respond to security incidents as they arise. Without further ado, let's dive into the world of log investigation and analysis. Welcome back. So the room we're going to be using for our illustration in this video is called Tempest from tryhackme. So if you go to the Tempest page, the first thing you get is the objective of this room, which says you are tasked to conduct an investigation from a workstation affected by a full attack chain. And if you scroll down, you get a list of tags from tags 1 to 9, ranging from introduction to the room to log analysis, tools and artifacts, malicious document, down to action on objective, meaning the fully owned machine. What we're going to do first of all is to ensure that we're connected to this tryhackme machine, and in order to do that, I'll simply go to the tryhackme.com/access to see my status. So we can see that we are not connected to the tryhackme network. I'll just simply go to my command line and make sure I am at the location where I have my OpenVPN configuration file. So if I ls, you get my configuration file for this account. So I'll simply use the administrative privilege, then the OpenVPN command, then we supply the name of our configuration file. Hit the enter key, supply our sudo password, and just like that we are connected to the network. So I'll just refresh this page. Good. So we are now connected to the tryhackme network with the IP address 10.8.55.29. So now I'll go back to my Tempest room and let's see what we have on the introduction page. So on the introduction page, we have tax 1 talking about introduction to the room, which is this room aims to introduce the process of analyzing endpoint and network logs from a compromised asset. Given the artifact, we will aim to uncover the incident from the Tempest machine. So we have a name of the machine. In this scenario, you will be tasked to be one of the incident responders that will focus on handling and analyzing the captured artifact of a compromised machine. So the focus on this room is window event logs, the sysmon, Wireshark packet operation, and the brim. So if we scroll down, we have investigation environment. For this incident, we have provided a window machine at your disposal. You may deploy the machine by clicking the start button in the upper right hand corner of the task machine. So we have it right here. So I'll just scroll up and click on the start machine. So we'll give this some time to load. Good. So we have our attack box launching by the right hand side of the screen right here. Okay, great. So now that our attack box are successfully loaded, what we need to do is to head to the task 2. And on the task 2, we have log analysis. So if I open the tab right here, we have two main topic of log analysis, which include the log analysis and event correlation. So we're going to be taking a look at these two terminologies briefly. So I'm starting with log analysis. So the log analysis, it is a process of reviewing and analyzing log files to identify patterns and trends, and also to troubleshoot issues. So log files are generated by various systems, applications, and devices, and they can contain information about our system and application activities. performance, errors. So by analyzing this log file, you can gain insight into how your system and applications are functioning, identify potential issues, and you can also determine the root cause of problem. So when we're talking about event correlation, we're talking about the process of analyzing log files from multiple sources in order to identify relationships and pattern between different events. So by comparing and contrasting log data from different systems and application, you can gain more complete understanding of how these components are interacting and identify trends and anomalies that may indicate problem or potential security threat. So when we are referring to window log files, we have two basic kind of window log files. We have the sysmon and we also have the window log file itself. So I'll just be discussing these two types of log files. So I'm starting with the sysmon. So the sysmon is a Windows system monitor tool that can be used to monitor and log system activities. It is particularly useful for security purpose. It can also provide detailed information about processes, network connections, and other system activities. The window logs records activities and events that occur on the systems or on the Windows system rather. These logs can be generated by various system applications and devices, and they can contain information about systems and application activities, performance, and errors. There are several different types of window logs, ranging from the system log itself, application logs, security logs, and setup logs. What I'll just do is I'll scroll down and just click on completed. So I have read and understood the concept of log analysis and event correlation. So moving to task 3, task 3 has to do with tools and artifacts. And the first topic we have on the task 3 is compare by hash. So before conducting the investigation, one of the most important steps is to compare the artifacts by their hashes. It is common practice to verify if the artifacts are expected as it is. And we have some command line written in PowerShell that we can use to find the hash value of a particular artifact. Here you can see a typical example right here. So I'm just going to be skipping this till when we get to the question and answer section. So I'll just move ahead to tool sets. We have about 4 tools listed here: the EVTX, ECMD, Timeline Explorer, Sysmon View, and Event Viewer. I know most of you are familiar with the last two, so I'm just going to be explaining what these first two tools are. So starting with the EVTXECMD tool. So it is a command line tool which passes window event logs into different formats such as CSV, JSON, or XML. You may use this tool in conjunction with the Timeline Explorer. So now what is the Timeline Explorer? The Timeline Explorer is a GUI based tool that functions as a data filtering and navigating application to ease incident responders in handling raw data. So meaning that after converting your artifact, which is your log files, from the .evtx to either CSV or XML, you can either pass this artifact into either the Timeline Explorer or the Sysmon view, depending on the file format. So if we move ahead, you can also see the command for using the EVTX ECMD tool and also the timeline. So we have our a diagram showing the Timeline Explorer. We also have some diagram demonstrating how we can convert our window logs from the event viewer, how we can export it to the XML, and how we can import this into the Sysmon view for better analysis. So moving straight to the question and answer part, we have the first question, which says, what is the SHA-256 hash of the capture.pcap.ng file? So we have, if we double click on the incident file right here, So you can see that we have three files on our remote machine. We have the capture, we have the sysmon, and we have the Windows log files. So I'll right click on the Windows, go to properties, and you can see the file formats to be .evtx. So now we are being asked, what is the SHA-256 hash of the capture.pcap ng file, which is the first file we have here. So in order to do that, we just fire up our PowerShell, and we use the command. We can grab our command straight up from the room notes. So you can see it will specify the get file hash. We also specify the algorithm, which should be the SHA-256, and we specify the file name right here. So we're just going to ls to see the list of what we have. We can change our directory to desktop. So we can ls, we can cd into the incident files. So ls, and we have our three incident file here. So we are looking for the hash of the capture.pcap ng. So get file hash, specify the algorithm to be SHA-256. Then we specify the capture.pcap ng, and we hit the enter key. So as you can see, this generates the hash value for that specific artifact. So I'm just going to copy, Control C, and we'll head back to our question and answer section and paste this right here. Submit. Okay, that was correct. So what is the SHA-256 hash value of the sysmon.evtx file? So we can repeat the same command and just change the name of the file to sysmon.evtx. So we get our hash value. Just grab this, copy, and we paste. And lastly, we have what is the SHA-256 hash of the windows.evtx file. So the same process, and we just change this to windows.evtx. So grab the hash, we paste, submit. Okay, great. So that is the end of the task 3. So we'll move straight to task 4. The first question on task 4 says, the user of the machine was compromised by a malicious document. What is the file name of the document? In order to do this, to get our files in order, let's expand our view. So this is just going to launch on the new tab. Okay, great. So I can make this bigger. And so what I'll do now is to navigate to the directory we have our tools on this machine. So I'll just cd, do a simple directory transversal to the root folder, and can ls. So I can cd into tools, can ls, cd into the evtx because it's a directory, and we can ls to see the file content. So on the file content, we have the maps, we have the evtx cmd dll files. So we also have the evtx ecmd.exe and the runtime config.json. So we're going to be using this particular file right here to execute our conversion. And if we go back to the room, we have a specific kind of format. Okay, on the tags 3, I guess that's on tags 3. Okay, great. So we need to specify the name of the application, which is the evtx ecmd.exe. We specify the file name and we give the full path to that file. So we specify the format and also the location we want to save our file and the file name. So starting with the first one, I'll just clear the screen. So CLS. So we can go with the first one, which is the name of the file. So ./evtx.cmd. Then we specify the file location, and I can grab the location from here. An unstable network connection. So sorry about that. So I'll grab my location, copy this, and paste right here, and we'll specify the name of the file. So we want to convert the sysmon sysmon.evtx. So I'm just going to close my quote. You might be wondering why I'm putting this location in quote. That is because of the space between the incident and file name right here. So what next? I need to specify the CSV and also the location we want to save our new file to. So I'm just going to specify the CSV format. Then the new location, we're sticking with the same location, the incident file location. We also need to specify the new file name, which is the CSVF, then the file name. So we are using the -CSV file and the new name, which is sysmon.csv, and we'll just hit the enter key. Okay, so we have an issue with our command. Let's change this to lowercase. So CSV output will be saved to this location. Just give it a couple of minutes. You can see the file has been generated, but it is still populating all the artifacts into the sysmon.csv. So I can refresh. It's still loading. Conversion is still going on. Okay, so while that is going on, we can also convert the sysmon to the XML file format. So in order to do that, we just open the sysmon using the event viewer. So we have a total number of 2,559 events on the sysmon.evtx artifact. I'll give it time to fully load and I export to the XML file format. Okay, great. So I can use the save all events as. So give it a name. So give it the sysmon also. So I'll specify the incident file folder, and lastly I'll change the file type to XML. Then I can hit the save. No display information. So I can close this now. So we'll just take a break and we'll be back after the XML and CSV file have been converted successfully. So the CSV file have successfully exported. We're still waiting for the XML file to export. So we have the CSV file to be 3,533 kilobytes. This is approximately 3.5 MB. So without wasting much time, let's import this into the timeline explorer. So I'll just fire up the timeline explorer right here on the taskbar. And before we pass the data into the timeline explorer, so this is what you get when you successfully convert your EVTX artifact into a CSV using the EVTX ECMD application. So let's head back to our timeline explorer. So we can go to the file, we can go to open, and we can go specify the incident file, and we specify the sysmon.csv, and I'll click on open. Okay, great. You can see that we have our information in columns, and we have a tiny search box here which you can use to find a specific string from this list of events here. And we have different columns such as the process IDs. We have some columns talking about the source IPs, destination, username, map descriptions of the artifact. We have process ID. I've said this earlier. We also have I think we have a section for execution information also. And we also have payload data, which has to do with hashes. We also have our event data. We have our source file location. You can see the sysmon.evtx all over this column right here. So this is a simple way you can convert your data to a CSV format and load it into your timeline. So the next thing we're going to do is to answer our first question. But before we do that, let's confirm if our XML file has been fully converted. So I'll just refresh. So we still have less than 1 MB for the XML document, meaning the conversion is still in progress. So let's just head to the question section. Let's head to the question section on task 4. We have the user of the machine was compromised by malicious document. What is the file name? And if you go to the investigation guide here, we have the malicious document has a doc extension. The user downloaded the malicious document via Chrome. The malicious document then execute a chain of command to attain code execution. So the first thing I want to do is to search according to the .doc, because if you scroll down, the question was asking the user of the machine was compromised by malicious document. So sorry about that. I can just reconnect. We have a timeout. Okay, I'm still connected. So what we can do is to search according to the string .doc. So if we filter according to .doc, you can see that we now have limited amount of log file to choose from. And so we are looking for a malicious file that's carrying the extension .doc. So I'll just scroll through to execution information. So if you go to execution information, we have just one information right here, and if we double click on this, you get the full description of the executable information. And you can see that this application winward.exe was used to execute this particular file. Free is it magiculous.doc? I don't even know if I pronounced that correctly, but this is what we are looking for. So I'm just going to copy this and paste that into the box right here, and we click submit. Okay, that was correct. So what is the name of the compromised user and machine? And we have a format which is username hyphen machine name. So if we go back to our remote machine, on the timeline explorer, we have the owner of this account to be Benimaru. So I'm just going to copy this and paste that right here and use the hyphen Tempest, because Tempest is the name of the machine we're working on. So if you want to actually confirm this, you can go to the question above, or you go to the introduction section, and we have a domain name. Let's see, where do we have it? Is it an introduction, or probably here? Okay, it's definitely on the introduction. Okay, I think I'm fine. Control F, Tempest. Okay, yeah. So we have given the artifact, we will aim to uncover the incident from the Tempest machine. So I'm just going to use the Benimaru hyphen Tempest, and I'm going to submit that. And that was correct. So we'll move to the next question. It says, what is the PID of Microsoft Word process that opened the malicious document? So the process that opened the malicious document is the winword.exe, which is the application used in opening the malicious document. So we are looking for the process ID for this winword.exe. And one thing we can do is to search according to this application name. So we use the winword.exe, and we can now trace this to the process ID section. So we're just following the arrow right here. You can trace it here. You can see that it has the process ID of 496. So I'm specifying 496. Submit. And that was correct. And the next question says, based on the sysmon log, what is the IP4 address resolved by the malicious domain used in previous question? So if we head back to our machine, we should be able to answer this using the sysmon view. So let's check the condition of our XML document. So this is yet to load. So what I'm going to do is delete this, and we can convert this sysmon.evtx one more time. Make sure all the data are loaded before converting to XML. So I guess they are now. So save all as, specify the incident file, still give it the name sysmon, and we'll specify the file type XML. Save. So I guess I can use English. Okay. Okay, so let's hope that load faster this time around. Okay, so it looks like the XML file has successfully been exported. We have the total size of 3,142, which is 3.1 MB. So we're just going to feed this into the sysmon view to see if we can have meaningful information from the sysmon view also. So let's load up the sysmon view. So while that is coming, let's take a look at the question one more time. And the question is, based on the sysmon logs, what is the IP4 address resolved by the malicious domain used in the previous question? We have a malicious domain that is associated with the process ID 496, which is the winword.exe. So let's head back to our machine. Okay, good. So just scroll up a little bit. Can we make this bigger? Okay, good. So we go to file, we go to import sysmon log, we go to desktop where we have our incident file, and we import the sysmon.xml file. Open, I'll click on import. So we have imported 2,559 event, which actually is the total number of our event from the event viewer. So I'll click on OK. And so let's look for winword.exe, which is the process ID 496. So if I click on the winword, I click on the image part, and I click on the session GUID, we can see, so we have summary of our event, which says on the winword.exe on the Tempest machine, the summary of event is DNS query is 4, file created is 1, file stream created is 2, network connection detected is 15, and the process created is 1. And we have a source IP right here, 192.168.254. We have destination IP. So if we scroll down here, you can see the DNS query here that happened on the 6th 2022 has to do with the ecs.office.com, which is a legitimate domain. So we'll just move ahead to look for another DNS query. Okay, we have another DNS query right here at 4:59 29 p.m. Which resolved to fishstream.xyz. Of course, the URL alone look suspicious, so we're just going to grab the destination IP, which is the one. Can I grab that? Okay. All right. Copy. So which is 167.71.199.191. So I'm just filling that in here. Of course, that's correct. So we can cross-reference this to the timeline explorer. So I can just, let's close this, head to the timeline explorer, and we can just search for that specific IP address, find, and you get all the events relating to that IP address. You can see it is associated with the fishstream.xyz domain. So we are moving to the next question. What is the base 64 encoded strings in the malicious payload executed by the document? So the easiest way to get this is to just go to the timeline explorer, and we just search for base 64, find, and we have just one event relating to base 64. And if we navigate to the execution information, this is the source file. Okay, nothing here. Source file. Okay, yeah, I have it here. I'll just double click on the execution information, and we have our base 64 string right here. So I'll just grab this to where we have the double equal to, copy, and paste. Okay, that was correct. And lastly, we have what is the CVE number of exploits used by the attacker to achieve a remote code execution. So I can go back to our base 64 page right here, and we have a particular application that was used right here, which is the msdt.exe. So I can just grab this, and before I make research on it, we have your int right here. It says external research needed. Observe the parent-child relationship of the winward.exe process and execute malicious base 64 payload. So I can just open a new tab, and I'll just paste that right here, and we're looking for the CVE. And the first thing that come up is the CVE 2022-30190 Microsoft Support Diagnostics. So without further ado, let's grab this. And do we have a format? Of course we have a format, so we are removing the CVE. Submit. And this marks the end to the part 1 of this video. Please be sure to check back on our channel for the next part of this video, where we'll cover the tax 5 to tax 9. Okay guys, that will be all for now. Thank you for watching. If you like or learned something new, please ensure you like, share, and leave a comment. And if you're not already a subscriber, please hit the subscribe button down below to join our community and get exclusive benefits. Your support helps creating content you love. Thank you for your help, and I'll see you in the next video.